Hello, I'm Ron Vale, and now we're in the laboratory at a microscope, and we're going to go through the steps of how to set up color illumination. Now, the main goals of color illumination are twofold. First of all, we want to focus this condenser lens so the image of the field diaphragm is projected on the specimen plane, so that when we open and close this field diaphragm, we can see a clear image of that field diaphragm through the eyepieces of the microscope or through the camera. Now, the other goal of Kellerer is to have even illumination of the specimen from the illuminating source. And the way we do that is by projecting the image of the lamp onto the front focal plane of the condenser lens. And remember, light diverging from a focal plane will emerge from a lens on the other side as parallel light, and that's what we want. We want parallel light bathing the specimen because that provides the most even illumination, and the light source will be completely defocused. Now, in this particular microscope, the light source here is and the lens is perfectly positioned so that when we have the field diaphragm in proper focus at the specimen plane, the light source is also correctly imaged onto the front focal plane of the condenser. So now let's go through this step by step. So I'm going to be imaging this sample, a stain section of mammalian taste buds with a 20x objective lens. So I'm going to put the specimen on. I'm going to make sure that the cover slip is facing the right direction towards the objective lens. And then the next thing is I'm just going to make sure that I look at the system so that I know everything is set up properly for bright field microscopy. First of all, there's an automatic shutter here, so I'm going to make sure that's open. And I know it's open if I can see light down here. And there are various filters here. Here's a green filter and a neutral density filter. For the start, I'm just going to take those out of the light path. And there's some other things in the system here. Here's a polarizer which we'll need for DIC microscopy, but right now I'm going to make sure for bright field that it's out of the system. And this condenser turret also has different settings. Some of them are for phase microscopy or DIC, and I'm going to make sure it's in the right setting for bright field microscopy. So now everything is set up here. The first step in Kellerer illumination is to focus on the specimen. So to do that, I'm just going to make sure that I have enough light going through the system so that I can see things properly. So I'll open up the field diaphragm. That lets through more light. I'll open up the condenser diaphragm. And this microscope has an adjustable light source on the other side. So I'm going to try to adjust the light so I can now sit down at the microscope and be able to have the right amount of light to focus. So now I'm going to focus on the specimen here with this focusing knob until I begin to see the specimen getting clearer and clearer until finally, there it is, it's snapped into focus. So that's the first step of setting up Kellerer, is being in the correct plane where I can now image the specimen. Now the next step is I have to adjust the condenser lens to the right position. I know it will be in the right position when the image of the field diaphragm is in clear view in the specimen. So what I'm going to do here is first of all close down the field diaphragm. And initially I can't see it at all. So now I'm going to adjust the condenser lens. I'm going to bring it down, and I can see the image getting brighter and brighter. And I can see the edges of the field diaphragm come into focus. Okay, there it is. So that's the second step of Kellerer illumination. But you can see here that the image of the field diaphragm is not perfectly centered. It's a little bit off to one side. And that's because this lens is not perfectly in alignment in the optical train here. So there are a couple adjustment screws right here that allow me to center and move the position of that condenser lens. So I grab both of them, and now I can kind of move them one way or the other until I see the condenser, the image of the field diaphragm, come into the center of my field of view. In the next step, then, I'm going to open up the field diaphragm. And the general rule of thumb is to open up the field diaphragm just past the field of view. Either whether the field of view is for your eye or for the camera. But you don't want to open it up beyond that, because then you just end up not contributing to the image and just getting extra glare from light passing through the microscope that degrades the image. Now, the last adjustment that we may want to make is to change the opening of the condenser aperture. So there's an iris here that can open and close. And in bright field illumination, we may want to have this open about 3/4 of the full opening. And we can adjust it to some extent based upon how the image looks. Because opening and closing the condenser, as you'll see in another demonstration lab later in the course, affects both the resolution and contrast of the image. So we may want to adjust that appropriately so we get the right kind of image of the specimen that we like. In other types of microscopy, like high resolution, differential interference contrast microscopy, where we use computer enhancement of contrast, in that case we may want to put the condenser fully open. In some microscopes there may be an additional step, which is adjusting the position of a collector lens. In this case, the collector lens is not adjustable, but if you have a microscope that does have an adjustable focus of the collector lens, then we need to adjust that collector lens so that the image of the light source is projected onto the front focal plane of the condenser lens. So how do we know if it's in focus? Well, we need to image this front focal plane of the condenser lens. And the way we can do that is with not looking through the eye with regular eyepiece, but flipping in this additional lens, which is the Bertrand lens. And that focuses on the back focal plane of the objective, which is in the same conjugate plane as the front focal plane of the condenser lens. Once we can see the correct front focal plane of the condenser lens, and we know we're in the correct plane because if we open and close the condenser diaphragm, we should see that iris opening and closing when we have the Bertrand lens in position. And we should also be able to view the image of the light source itself, provided that there's no diffusing glass or something that's blurring the image. And at that step, we could then focus the collector lens so that we can now see the image of the light source clearly focused at the front focal plane of the condenser lens, which will also be in view in the back focal plane of the objective. And if I look through the eyepiece, I can see an image of the light source. I can see the little filament that's making the light. Now, I can't show that to you, but another way I could show that to you is if I defocus the condenser lens. So now I'm focusing the image of the light source instead of on the front focal plane, I'm focusing the image of the light source on the specimen. And if I do that, I take it out of focus, I can now see the image of the light source at the specimen plane on this piece of paper. And this is called critical illumination, which, as you can see, gives very uneven illumination because we can see all the features of the light source. So in summary, let's go through the steps again. So first of all, we put the sample in place, we adjusted the light intensity, and then we focused on the specimen. Next thing we did is we closed down the field diaphragm and we adjusted the position of the condenser lens looking through the eyepiece until we see the iris of the field diaphragm clearly in focus on the specimen plane. The third step is we now open up the field diaphragm just past the field of view. Finally, we adjusted the condenser aperture as well. The key thing now is not just to watch the lecture, but go find a microscope yourself and go through all of these steps in color illumination and practice them so it becomes just second nature for you.